Hello guys, welcome to my channel, and today in this video we will talk about exploratory data analysis. As you know, every field which is related to data analysis is one of the important part of that field. So today in this video we will talk about how can we become an effective data analyst, how to communicate with the data, how to extract something from the data. So first of all, the prerequisites are that you must be familiar with the data cleaning. You must be know some basic libraries like pandas, numpy, matplotlib, and seaborn. And if you haven't watched my data analysis data cleaning video, then you can click in the description where the link of that video is located. So first of all, let's start with the uh, opening my Jupyter notebook. So here I will search Jupyter notebook. Hence my Jupyter notebook will be opened here. Then I have already a data set available. I- and I will also give you that data set. So okay, where is the data set? Wait a second. In the archive, I think our data set is located. So here we will create a new file, and that file will be data pre-processing, data analysis. Yeah, you can call it exploratory data analysis. Exploratory data analysis. Now the prerequisites, the one of the important things is that you must watch video till the end. In this video I will not only show you the data analysis, but also I will show you the mindset which you can use to analyze the data. So first of all, the second request is to subscribe my channel and watch the full video at online. If you're not watching the video full video and online, you just download it. So it will actually cause my channel to be down. So it's a request that you must watch this video as an online. Okay. So first of all, import the libraries here. So first of all, I will import NumPy as NP, import pandas as pd, import matplotlib.pyplot as plt, and import seaborn as sns. Okay, so first of all you need to create a variable and where you will import that data here, pd.readcsv, and here it's actually a data set. The name of the data set is toy, but it's not a toy data set. It's about the different persons who are living in a different cities, and we will need to predict the price of these persons and also their illness, which means that if they are severe with something, if they are suffering from some illness or not. So in our data set, first of all, try to read the data. So here it has been clearly seen that the first thing is a number, which is nothing but a unique number column. The second is about the cities, the gender, then the age, the income, the illness. So from the data set, I assume that we need to predict the income here, because and that thing will tell you by the stakeholder who wants to sponsor the project. He will tell you that which project, which thing needs to be predict. You will have to create the model at the end. If I talk about the data science, we need to create the model, and our stakeholders will tell us that you need to create a model which will predict price or either which will predict the gender. It depends upon the stakeholders, and you will have to work according to that stakeholder. So let's assume the problem is we need to analyze. So I will also write this thing. We need to analyze the price of different persons living in different cities. Okay. So basically, when it comes to the data and exploratory data analysis, we do three type of data analysis: univariant, and bivariant, and multivariant. So univariant analysis means when you do the analysis of only one column here. So first of all, we will start with the univariant analysis. Univariant analysis. Okay, but before that, I will also tell you you have to do something. Uh, okay, we will start from here. So before starting the univariant analysis, I want all of you to check the shape of the data. It will actually gives you a lot of things. So we have a shape of the data which is nothing but we have 15,000 rows 1,50,000 rows and 6 columns. Apart from this, you can also use the describe function here. Describe function will give you the mean and standard deviation of all the numerical values in your data set. So here it has been clearly seen that a number is a unique value. We will not concentrate on a number because it's a unique value, and if I change the number, then it will not affect on the income. So we will not deal with the number. Yes, age is one of the important thing. Here we have a mean age of round about 45. If you round it, we have 55, 25 minimum. Percentile means, it is called the percentile means that 25% of data lies under 35, 50% of data lies under 45, 75% of data lies under 55. It actually tell you that how percent of data lies on a particular point. For example, if it tells you that 25 percentile is 35, that it means that 25% of data lies below the 35. Okay, now these are the concepts of a percentile here. So let's move along. Let's start with the univariate analysis. As I told you that if you think that I change the number, will it affect on my price? I don't think so. Because if the employee ID is 1 or 2, if I change the ID, then it will never, I'm just giving you the example of employee. It will never affect my model. So first of all, I need to remove the number here. Number column, df.drop, number column, axis is equal to 1 and in place is equal to true. Make sure to use the in place here because it will not update it if you have not using the in place here. After that, just df dot, yes, start with the univariate analysis. Now the first call, before that you can also check the info function. The info will tell you the data type. So the first is city. So when it comes to the analysis of you can say univariate of uh, object data type, then I will give you 2 to 3 columns or 2 to 3 recommendation which you can use. You can either use the value count. When it comes to you can use the value counts here. Apart from this, you can use the count plot to check how many count, and also you can also the same thing you can check with the help of value counts. You can also go with the pie plot here, pie plot. So these are the some things which will tell you about that how you can analyze the that what are the analysis of a particular object column. So first of all, let's start with that city column. Now I want to check that how many persons are from, how many different persons from different cities. So here we will go with the value counts. So it has been clearly seen that if you check these things now, it looks like an unattractive to us. So let's try to make it a little bit good. So for this we will actually create a figure here, plt.figure. Figure is nothing but it will tell you the figure size, the graph size. It will be 18 by 9. So we will create a count plot here, sns dot count plot. At the x-axis I want the df dot or df city. So it has been clearly seen with the count. Now it's look attractive. You can also change the title here, plt dot title. So plt dot title is the title will be counts, you can call it count of different persons from different cities. So it has been clearly seen that we have such type of code. So more, the one thing you will have to note that how many persons are from uh, on which city we have a large number of persons. So you can say in the data set we can clearly see that New York has a lot of ratio, San Diego is less than, and Los Angeles is one of the, you can say it's an average. Los Angeles and Dallas comes in average. So you will have to note that point that New York City, most of the persons are from New York City, are from New York City. The reason is that New York is the most developed, you can say one of the developed city of USA. You can also, and very less from San Diego. Maybe there will be less facilities in San Diego, so that's why there are less persons. And you will have to, and less persons from San Diego. There are also a possibility that there may be a less job opportunities in San Diego. That's why only few persons we can see here. So that was actually about the you can say the column of city. Now let's move toward the second column is you can also use the df dot columns here to check the columns. So now the second thing is the gender. So I will also use the plot for the gender. I will not use the value count because at the plot it gives me uh, you can say a pleasure to see the okay. So we will do sns dot count plot here, and sns dot count plot, and we will actually call it the gender here. These are actually for the categorical variables or multi-class variables, or the variable. These are actually for the object data type, you can call it. And the title will be uh, gender gender counts. Okay. Also, you can change the x label and y label. Plt dot x label. At the x, we have a gender here. I will also write it here. X is df gender. So we can also change the x label here. X label means here. So we will talk it the gender, and plt dot y label is you can say the counts. As a default, they will take the x axis and y axis your column name. For example, if my column name is gender, at x axis it will take gender, and count it will be taken at y axis. So let's check it. So it has been clearly seen that the male are more than the female here. The male are more than. You can also check with the value count. Now the these are actually related to the count plot. Now you wanted to do something different. You want to calculate the percentage. If you talk about the percentage, then the next thing which comes into our mind is actually a pie plot. Pie plot means pie plot gives you the percentage of an occurrence. So first of all, let's apply pie plot on male and female. So how to make a pie plot? First of all, you will have to create the counts here. The count. The counts will be nothing but df gender dot value counts. Okay, we have here the value counts here. Okay, dot value count. These are actually the counts here. After that, you need to calculate. You also need the values. You also need the values are, for example, male and female, and the values we will take from the counts, and we will call the values as indexes. So the indexes will be counts dot index function. So now our all the things are ready. Then first of all we need to create plt dot pie plot, and in the pie plot first of all you can click on you can enter the shift tab, and it will give you what which thing you can go with. So the first is the x means the data. So we will go with the counts here. The counts here. Labels will be nothing but my indexes will be the label, and r2pct is what's the value of r2pct as a default. I will check it here. Wait a second. Sometimes I auto percentage I actually forget to about auto percentage. I need to check the value here. So if you are not getting the value, then you can go with the plt.py, and you can search it here, and here it will you will go with the matplot documentation, and here you will get your desired things. So plt.py plot r2pct, where is r2pct? So it default value, where is the, it will actually r2pct matplotlib r2pct. Okay. Then you can also check here. You can use r2pct. Yes, there is the value 0.2% of f. It actually tells you about the percentage here. So we will use it this. I think I did not copy that, so we will paste it here. We'll actually generally write this. So percentage dot 2 f. So if I click here, then it will actually tell you, yes, it has been seen that 55.87% are from female, and we have a sorry, 55.87 are male, and 44% are female. You can also click, you can also write it here that male are more than the female, than the female. Now we have done with the, you can say, with the two columns. One is called uh, gender, and the other is the cities. Now let's move towards the next column. What is the next column here? You can click div.head, you will realize. Now we have an age column. Now if you check the df age info, then it will tell you that it is actually a continuous variable column. So for this uh, you need to you need to do two to three things. The first thing is, all you can either go with the distribution plot, and the second is you can go with the histogram. So I think I will recommend you to go with the histogram, because histogram will tell you that, it will tell you the persons from a different range. So let's try to do with the histogram. sns.histplot, sns.histplot, and in here we will take age as in column. So, and also I will take the KDE is equal to true. KDE will nothing but a line on the top of the histogram. So let's assume the histogram, and it has been clearly seen that salary, that the age, that most of the persons, that the average age which comes is round about 45, 44. It is actually considered to be the average age, and most of the persons, I think they that are, if you see, that are at the age of 26, 27. Most of the values at the age of 26, 27, and also we have some values that are at 63. So it has been clearly seen that most of the persons have the age round about 26, and also 63. It is round about these things. So that was from the age. Now let's move forward, check the income here. Now it is one of the important column. So we can also check the distribution plot here. We can check the histogram plot here, hist plot here. The video will be quite long, but you will have to kept patient about this thing. I don't know if it's patient or not. I'm quite weak in English, but I hope you understand. So here, yes, check the distribution. So in the y-axis we have a count. Count means how many times that particular value repeats, and income means we have the income. So it has been clearly seen that most of the persons, and 1 lakh is the most repeated value. I think 95,000 or 96,000, you can call it. These are the most repeated value. These are considered to be the most repeated value, and this is if you check the distribution, and their variance is, you can say, quite low. Their variance is quite low. And the second thing is, there may be some outliers, and if you don't know how to remove the outliers, then you can check the past video where I have removed the outliers. So it has been clearly seen that, you can also write it here, the average income, you can say the average income, you can call it, uh, it's around about 95,000. So now these and also there is one column remaining, which is called the illness. So illness is here. It is I think if I check it, it is one of the categorical column, and you can call it, you can check it, you can also actually apply this thing, this plot, or this plot with the illness. You can check the previous code and you can apply it. Now let's move forward. Okay, now that was from the univariate analysis. Now let's move towards some advanced things. So advanced thing is actually bivariate analysis. So here it has been clearly seen from here that you can also write it here. Always write it because it gives you a big thing, because whenever we have something in the mind, and if you write it with our own notebook, or we can you can say print it, it gives you a lot of idea, and it actually we remember it for a long time. So that's why I will always recommend you, whenever you find something, just write it. Don't think too much. Okay, so it has been clearly seen that we have the most of the persons are not ill. You can call it, they are not ill, they are normal persons, they are not suffering from any sort of disease here. So let's go with the bivariant analysis. Bivariant analysis means we will compare the two plots. We will compare the two plots. So I will give you the h1 heading here. If you don't know about h1 heading, you can search it on the html. You will find out there. Either here we'll start with bivariant analysis. Bivariant analysis, I think I made some sort of mistake in the spelling, but doesn't matter, because we are not here to check each other's punctuation or mistakes. We're just here to understand the data science. So first of all, I will recommend you to print the data. Now just analyze where the which column we need to predict. We need to predict the income here. We need to predict the income here. So I will recommend you that try to compare all other columns with the income. So okay, now let's first of all, I need to tell you something about it, something about the data here. So we have a data which includes the three columns that are usually object column, and the two are categorical column. So if you want to compare two columns, if you want to compare the two columns, one is categorical. Categorical means object or object, and the other is numerical, and the other is numerical. Then try to use bar plot, and try to use the bar plot. It will actually give you the average value of a numerical variable with respect to a category, with respect to a category in a in an object. For example, if I have a gender, then it will actually give me the average value of gender. And if I have a gender as male, it will actually give me the, you can say, the value as a male. And if my gender is female, then it will also give me the value as a female. So first of all, let's check with the cities here. So here I will actually first of all go with the, I will create first of all the figure here, plt dot figure. And in that figure, first of all, I will select the fixed size. It will nothing but, it's actually our plot size. It will be 18 by 9. Then we will actually create a bar plot, is sns dot bar plot, sns dot bar plot. At x-axis I want all these cities, and at the y-axis I want all the I want the income here. And let's enter here. It will take some time because we have one log. I think I have ssd, so that's why it's not taking any time. So we'll also for write a title here, just for the simplicity and just for the readability. And plt dot title is you can say bar plot, yeah, average income of each category. Average income of each category. So it has been clearly seen that since the mountain view have a high average, mountain view have a high average income, which means that it mountain view include understanding the problem, understanding the answer. You can say it has been clearly seen that mountain view has a high average. Mountain view has an you can, okay, I will write in a simple word, the people who are working In Mountain View city has a have high salaries, which means if their average is high, then we they have a high salaries. The reason will be multiple. I think that Mountain View is one of the expensive city, if you can call it. And the second thing is also there will be a multiple jobs. There will be many multiple jobs opportunities. If you compare it with the plot where I told you that most of the data are from New York, because most of the persons in New York is one of the big city of USA, and so that's why there are we have a data of many persons. But if you compare it with this thing, then we will realize that it doesn't matter. It doesn't matter how much of you have a data. It depends upon the income. So you can call it that the average income of each category with respect to city. So the Mountain View have a high price. So okay, now I have first explored the Mountain View. So let's go with the some other columns here. Now let's explore the gender here. SNS dot bar plot, and I had, okay, you can also do the same thing. You can explore it the same thing. And if I click here, hui means we label something. We create a legend here. Hui means I want to calculate all these things with respect to the gender. So let's check the magic here. Check the magic. It will actually tell you the price with respect to the gender in cities. So in Mountain View, you can say male are more capable to get higher salaries, average salaries than you can call it they are more capable to give high salaries than a female. So in short, we can say that how can we edit this? Also, the ratio of male is quite high as compared to female. That's one of the important thing. You need to check this thing, because as a data scientist you need to extract something from the data. And I think I extracted many things, not some things, 3 to 4 things. And we need to give all these things to our stakeholder so that he can understand. Now let's move towards the next thing. The next thing is we have a discrete continuous variable, age, and we also have income. So uh, let's I don't think so we need to check the income price with respect to the illness rate. First of all, let's check with the illness, then we will move towards the age, because I think I need to explain some more things in the age. So just create a bar plot here, sns dot bar plot. I will not create the bar plot of gender because I already understand their illness. uh, sns dot bar plot, and at x-axis I want the illness here, df dot illness. At y-axis I want the income here. So if I click here, it will actually tell me. So I think the income is for both is same. I think I need to use this type of figure here. I think. Okay, now the same thing we can do with the pandas data frame. How I can do? We can use the group by function. For example, if I want to check the df dot group by. For example, if I'm not getting the value correct here, just because I'm not taking I'm not you can say getting a value correct. So for this purpose, you will be group the group by here, and in the group by I will select the illness, the column on which we will use as a categorical column. So I will take the illness, and illness with respect to income. I with respect to income, I want a mean here. So if I click it, so it will be clearly seen that the mean value of the illness For the person who is not suffered with illness is 91,000, and the second is 91,277. The same thing you can go for the same thing you can go for the cities. Same thing you can go for the city. So we will get a lot of things. Apart from this, you can also go for the gender. So it is one of the important, also one of the important thing which will actually give you the exact price here. Okay, you can also go with the max here. You can, apart from mean, you can go with the max. You can also go with the min. It depends upon your analysis. And you can also go with the quantile, 0.25 percentile. So you can also go with the quantile here. You can go with the multiple things, but the fact is you need to know the terminology behind the reason behind these things, why you are doing these things. Now let's move towards the last column. The last column is the age. Last column is the age. Df age dot value dash counts. So if I check the counts, then most of the persons are at the age of 26. We have a data set. Now let's compare it. Let's compare it with the income here. So we will use the scatter plot for here. For this problem, we use the SNS dot rel plot. Rel plot is nothing but a regression plot, relation plot, and x-axis. I will. You can also go with a joint plot here. At x-axis, I will go with the age. Y-axis is all about the income here. So if I click here, it will actually give me a joint plot. Uh, it will actually combine the income with the age. Just to make it more readable, we can go with the scatter plot here. PLT dot scatter, and at x-axis I want to use the age, and at y-axis I want to use the income here. Okay. I made any mistake. I made some sort of mistake. That's why it give me an error. So you can see it's a scatter plot. So by comparing age and income, we are not getting this thing. But if I check here, then I can say that most of the thing persons are from 39, 26 age. So I think if I'm not getting a value, let's try to do it in a group by way. So with that we will maybe we will get some sort of value here for the age, for the average age. Df dot age, and we will compare it with the income here. Dot max. So dot mean means, so for every age it will tell you all these things. 91,164 is for the 25 age, and you can do a lot of things by using this data analysis. So that was all. I think we have discussed till now the univariant analysis, bivariant analysis, and let's go with the multivariant analysis. And one of the example I told you, it is also called the multivariant analysis. You can take it from here. You can do it from here, and I don't think so we need to do any sort of multivariant analysis still here, just because we get everything. But in multivariant analysis, I will give you some overview of some plots. And let's start with the multivariant analysis, which means that we have one more than one column analysis. So okay, let's go with the multivariant analysis here. So in the multivariant analysis, I can use a pair plot, but the reason is that the pair plot is only applicable for the continuous variables. It will actually compare every continuous variable with other variable. Uh, okay, let's understand. First of all, it compare income with the age. then age with the age, then it compares income with the age, and then income with the age. So it actually gives you some overview of the data. But I think I have concluded some things. Now what you have concluded, the first thing is the average age is round about 44, you can say, in the data set. The second thing is that mountain view have a high average price. Just because the mountain view is more developed, there maybe there are multiple jobs available. And the third thing is that if you are ill, then it will never affect your job, because the ill and the same persons have same sort of average salary. And the fourth thing is, which I conclude, that male have a higher ratio than female. So okay, I explained you all these things. So this actually a general introduction, a crash course to data, exploratory data analysis. If you have liked it, then you can subscribe my channel and hit the bell icon. Today we'll talk about bar plot, scatter plot, and there are multiple plots available. You can search it on the Google, but I'll explain you some of the important things, some of the 4 to 5 plots which are necessary to extract the information. And that was all from me from my side. So subscribe my channel, hit the bell icon, and wait for the next video. The next video will be about will be come tomorrow. It's about the model training, and there I will explain you everything, that how to train a model. So till now, bye bye.